Hello, everyone. Thank you for joining our webinar today. It's great that you're able to dial in for part 2 of maintaining your atomic absorption system. Today we'll be going over Graphite Furnace AA maintenance. I'll first give a bit of an overview on the atomic spectroscopy line of products, a bit of a historical review on AA instrumentation, our current AA instrumentation, talk about promotion really quickly, and then get right into the meat of it, where Sarah Howden will be discussing it in more detail, Graphite Furnace AA. So it's great to see that from the poll that is something like 86% of you have an AA, so that's really encouraging. Hopefully this information that's presented here will help you when maintaining your Graphite Furnace AA. And note that this will be available on demand. We'll send you a link follow-up after the webinar today. So just a little bit of history. PerkinElmer came to the market in 1961 with the Model 214 atomic absorption system. And then further developments in AA, really the big one where you see AA usage take off was in 1963 with the Model 303. So now today, our current atomic spectroscopy portfolio has grown considerably from the 1963 with the Model 303. You'll see with in AA, there's multiple models of atomic absorption available, multiple techniques, from flame furnace, dedicated mercury analyzers, and now there's ICP OES and ICP MS instruments. The family of inorganic instruments is shown here. You can see the Pinnacle series on the left, Avio ICP OES in the middle, and Nexion series ICP-MS on the right. Today we'll be, of course, talking about the Pinnacle 900 primarily, because we're talking about Graphite Furnace. There's a variety of automation offerings PerkinElmer has, from a variety of auto samplers to automation and sample introduction on flame units, microwave preparation systems, and mercury and hydride systems for various elements. Some software updates, just a quick software update. Synergistic software, just to let everyone know that a lot of harmonization has gone on with software. So those of you with older systems with WinLab software, there's been a lot of updates over the years and obviously gone to a more modern software architecture, more easily used, and data is more easily exported from the system. For ICP-MS, we have some new application modules, specific research areas, nano, single cell, and then method validation that most labs need to do some sort of method validation. So there's method validation calculations and reports that can be created in the software. In addition to that, for those of you who need the 21 CFR Part 11 compliance, in the last few years, there's been a lot of updates in our software offering. Just a quick indication on the Pinnacle 500. Here's your Pinnacle 500 here. Very small footprint. Our Pinnacle series has fiber optic light transfer, so both on the 500 and 900 to help reduce the size of the instrument, so we don't have to worry about mirrors. And a touch system will come with a touch-based interface, as you see here, or a full software option, depending on the application and desire of the laboratory. All the systems have lamp and spectrometer auto alignment and gain, so there's no fiddling with lamps or adjustments needed there. They're just pop the lamp in and the system's ready to go. The system here is designed with corrosion resistant and robustness in design. So, a lot of the labs that are using AA are quite rugged or acidic type environments. For the Pinnacle 900, we have a couple different models. So there's a flame only, the 900F. There's a furnace only, which is the Zeeman THGA 900Z. And then we have stack design. So there's a stacked flame furnace design. There's one with a 900H with their HGA type furnace, which we'll talk about briefly or during this call. And then the 900T, which is a THGA type furnace with Zeeman effect background correction. Variety of unique features in the systems, and the 900 has an 8-lamp system compared to the 500 with a 4-lamp system. And the flame versions, the one with flame, have a flame burner head optimization, so auto optimization of the flame position, which can be handy from changing from method to method. There's stable temperature platform furnace, so and longitudinal THGA, transversely heated graphite atomizer in the Z and T models, and as I said, there's stacked designs. Again, all models have a fiber optic light transfer to kind of reduce the footprint of the instrument. As I was mentioning, the revolutionary optical system of the AA, they're also real-time double beam systems. They have a very high transmission across the wavelength range. These fiber optics were selected and designed for exceptional optical performance. And in addition to the optic system, to getting the light to the detector or the monochromator, in the end, there's a high sensitivity solid state photodiode detector. The two furnace types, as you can see on the right, there's transversely heated graphite atomizer and the heated graphite analyzer. The Zeeman transversely heated graphite analyzer furnace really gives you those exceptional detection limits. They reduce the interferences and memory effects because of its good heating profile, as you can see here on the right. Don't have those cool zones as opposed to HGA furnace, where you have some cool zones on the end, which could lead to condensation. And just a note on promotions, PerkinElmer, I can't, go over all the promotions, but, in general, we know a lot of people have some aging equipment out there. So regardless of the, age of the AA, ICP, ICP-MS, we do have, trade-in value. A lot of them do have some sort of value associated with them. So, please reach out to your PerkinElmer representative for information there. And now I will switch it over to Sarah.
Hello, everyone. All right, I'm going to talk about furnace maintenance. So let's go to the, let's see now, there we go. Oh, now, trying to, all right, let me see. Having a little problem here. Sorry about that. All right. All right. All right, let's try it again here. All right. Sorry about that. All right, please be patient here. Oh, try again. Okay, I think we got it good now. All right, sorry about that. All right, let's go back. All right, sorry. All right, so we have two furnaces. We have the HGA furnace, which is on the left-hand side. The HGA furnace corrects for background absorption by a continuum source. The THGA furnace, which is on the right-hand side, corrects for background by an AC magnet. Now, something that's new with our graphite tubes, we now have a dot indicating the orientation of the graphite tube. So when you place the tube into the furnace, the dot is always in the back. If you have an older graphite tube that doesn't have the dot, then make sure that the platform attachment faces the back of the furnace. When you do this, the platform will be slightly higher in the back, and that's the orientation that you want. So that's going to apply to all types of tubes. Now, with the Hga system, you have to use an Hga tube alignment tool, and that will make sure that the dosing hole is directly under the hole in the contact cylinders. And when you use the alignment tool, you want the flat part of the tool to the left. And of course, you always have to remember to remove the tool, otherwise it's going to melt when you heat the furnace. So these are pictures of the standard THGA tube and the end cap tube, and you see now our current tubes have the dot, indicating that the dot goes in the back. And again, if you have older graphite tubes, you want the platform attachment to the back of the furnace. And again, that way you'll have the platform slightly higher in the back. And you have your tool to either remove or insert the THGA tube. Always condition a new tube. And so the conditioning program is built into the software. And what you will do is just when you insert the new tube, you'll tell it to condition the tube. And also it's recommended that if you haven't used the tube in a while, condition it again before you use it. And it will go through, and what it will basically do, heat up, cool down, heat up a little bit higher and cool down and so on. So always condition a brand new tube, or if you haven't used it for a while. Okay. Now, the other thing that the software will do is it will track how many cycles you've used on your graphite tube. Now, that number can be reset, or you can edit that number, because sometimes you'll remove a tube, you'll put a different graphite tube in for another type of application, so you can edit that number. The contact cylinder cycle number you cannot edit, because once you insert contact cylinders, they should not be removed and inserted again. So it should be a one-time insertion of the contact cylinders. Now, you should always clean the contact cylinders before you put in a new tube, and you can either use dry Q-tips or you can use foam swabs, and we have a part number for the foam swabs. If you have severe deposits, you can use some isopropyl alcohol to clean the contact cylinders, but you have to make sure that the contact cylinders are completely dry before you put the new tube in and before you condition the new tube and run. It's always a good idea to check for contamination, and of course the amount of contamination you have will vary by element. So the first thing you want to do is a dry firing, and that's where you go through the complete program without injecting any solution. And you should not see a peak from this dry firing. The next thing you'd want to do is use your select location to tell it where the blank is. Now, if you're using a modifier and you have it indicated in your method, it will inject the modifier as well and select location. So you would inject your blank and the modifier, and again, hopefully you will not see a peak. If you do a few more, just because a lot of times the peak will go away. You know, it could be some contamination in the sampling papillary or something like that. If you still have contamination, then you have to figure out where the source of the contamination is. Maybe it's from the DI water, maybe it's from the modifier solution, maybe it's from the sample cups. And the sample cups should be washed in 10% nitric or soaked in 10% nitric overnight before using. And of course, always make sure you've told the instrument what tray you're using, because if say you're set for, the wrong tray, then you're going to end up hitting the tray rather than going into the sample cup. You have to be careful about contamination because you're looking at very low levels with the furnace. So the water should be 18.2 megohm purity. The acid you use should come in a Teflon bottle with a certificate of analysis. The modifiers you use should be high purity, and you make them up in small batches because every time you open up the container, you can contaminate the solution. So that's when you're going to soak your auto sampler cups. And the environment that you're working in also is very important. You want to make sure the vent over the instrument is not a source of contamination. Some people will even cover the furnace when it's not in use. You should use gloves when handling graphite tubes, contact cylinders, windows, any other furnace components. And the geographical location could be a source of contamination. If you're looking at sodium and you're near the ocean, that could be an issue. And of course, the operator could also be a source of contamination. Now, the Hga window is held in place with a bayonet mount, and you always want to remove the window from the mount when you're cleaning it. And you can clean it with high purity alcohol, or you can use a very dilute solution of detergent with a 100% cotton ball, and then rinse well, and then of course dry. Make sure there are no streaks, make sure there are no scratches. And when you're set up on copper, the window should not have an absorbance greater than 0.1. If it does, then what you would do is you would measure the absorbance without the window in place, and then with the window in place, see what the absorbance is. If it's greater than 0.1, then you either clean it again or you replace it. With the Siemens system, you have a window key, and you have very small threads on the holder, so you want to make sure you don't cross-thread the holder. You don't want to over-tighten it. And again, remove the window from the holder when you're cleaning it. Okay? And what you're going to do is hand tighten the holder back in the furnace assembly, and then you do a little bit of a turn beyond that with the tool, the window key. Rinse water. Now you have a few choices here. One choice is within the 2.5 liter bottle, you can use 2.5 mils of Triton X100 and 5 mils of ultra pure nitric acid along with the DI water. You can also use a small amount of isopropyl alcohol. If you're using just DI water, you must change the water daily. Otherwise, you'll have bacteria growth in the water. And if you have an organic solvent that you're using, make sure it's compatible with the container that you're using. Precision is very important in furnace, and you should always be running replicates with furnace, typically 3 replicates. So the precision you should expect would be 2% or lower, with a absorbance of about 0.2 peak area, and with at least 5 microliters of sample or standard. Less than 5 microliter, you will not have the accuracy, the same accuracy and precision. So generally, you always want to dispense at least 5 microliters. Drying temperatures and times have a great effect on precision. So you always need to check your drying temperatures and times. Also, if you have a pyrolysis temperature that's too high, you'll lose some analyte and you will not have good precision either. Sampling capillary alignment, depth, and condition will also affect precision. And the auto sampler tubing cannot be crimped. And you must always have the front and rear ferrules at every connection, and make sure your check valves are also in good condition. If you have high levels of background, that also could affect precision as well. We do have a tube cutter, and that will enable you to get that bevel in the tubing, so that the inner tubing, you want that to be 7 millimeters long, and you want to have a slight bevel. And when the sampling capillary goes into the graphite tube, you want to make sure that the open part of the bevel is to the back of the tube. So, and if it's misaligned and it ends up hitting something, what could happen is you can end up breaking the outer sleeve at this point. And if you do that, really the capillary is not going to be any good anymore. So, because the outer sleeve will actually go from this point all the way up here. The inner tubing feeds through and then goes all the way back to the pumps. So you've got to make sure that this sampling capillary is in good condition. That will greatly affect your precision. So the open part of the bevel is directed to the back of the tube when it's inserting your solution. And what's very nice about the Pinnacle systems is we have a camera, so it's very easy to track looking at the dispensing of the solution to make sure it's dispensed completely. What's important is the height of the capillary needs to be such that the last droplet that gets dispensed will touch what is already in the tube and get pulled off, because you don't want that last droplet clinging to the sampling capillary, because then it will end up on the dosing hole. You also don't want to make sure that your sampling capillary is not too low, because you don't want it submerged in the solution that's already in the tube as well. And drying, even though you can see it dry to some extent with the camera, it's always best to verify drying by holding the little mirror over the dosing hole and looking at the vapor with the mirror. So this is an example of seeing the vapor coming off during the dry step. And so this little mirror will fit very nicely, especially on the ZL furnace, but you can use it with the Hga furnace as well. You just have to hold it a little bit at an angle. And you want to see the vapor within 15 seconds of the first step. You want to stay at the first step as long as you see vapor. So you don't want the first step to end before the vapor is ended. Then you'll go into the second dry step. And if you see vapor in the second dry step, you want to make sure the step is 15 seconds beyond the point where you don't see any more vapor. Very important that you dry your sample completely without any kind of splattering. And ideally, you don't want to see large droplets on the mirror either. That could indicate that it's drying too fast. So drying is extremely important. Pyrolysis is important as well. You want to make sure the temperature is not too high. And with that, you would do a pyrolysis study through the software. But drying always needs to be checked on your standards and on your samples. Now, there are two different kinds of check valves. You have solvent resistant, where you have a metal spring, and you have acid resistant, where you have a plastic spring in essence. And the solvent resistant check valve, you could end up having a little sleeve there, or excuse me, the acid resistant one. There could be a little sleeve in there, and if you remove this part of it, the sleeve might get stuck up inside. So if you have trouble inserting in another check valve, that sleeve might be inside there. And when these are inserted into the rinse pump, you always want the ruby ball to be on the bottom. Now, of course, if you have the screw threads, you don't have a choice of how you insert it. But if you have one that doesn't have the screw threads, which is the other check valve, then you want to make sure that you don't have it upside down, so that the larger check valve goes on the top of the rinse pump and the smaller one goes on the bottom. And that's the one that you have to be careful that you have the ruby ball on the bottom when it's inserted. Now, the sample pump does not have check valves, so you want to make sure that you don't put check valves in the sample pump. It has inserts. All right, so getting ready to change your contact cylinders. First, I'm going to talk about the Hga Furnace. So with the AAnalyst 700, you can tell the software to lower the furnace, but you really don't need to because the contact cylinders are going to be on the left and the right side of the furnace. On the Hga 900, it's easiest if you swing the furnace out of the sample compartment. The Pinnacle 900H, you change the contacts with the furnace in place. And of course, always remove the furnace windows before you change the contacts. All right, before the furnace is turned off, and you would turn it off by the standby switch in the front and the circuit breaker in the back, open the furnace and remove the graphite tube while wearing gloves. If the furnace has already been turned off, then the argon is going to have to be turned off and one gas hose will have to be removed to relieve the argon pressure. Make sure the right-hand furnace block can be pulled to the side so the contact cylinders can be accessed. Use a small screwdriver to lever the graphite shield ring from the left-hand contact. Make sure you do not damage the furnace coating when you're removing that shield ring. And the shield ring covers the gap between the left and the front and the right hand contacts when the furnace is closed. So the left and right hand contacts do not actually touch one another. There's a little gap between them. And that's why you have the shield ring, to cover that gap. And on the left, you see the shield ring in place. And then on the right, you see without the shield ring, you see the little gap between the two different contact cylinders. Now, these are the tools that you will need to change your contact cylinders, and then on the right are the contact cylinders themselves. So the first thing you're going to do is you're going to remove the right-hand contact cylinder, and you're going to place the dome-shaped extractor on the bolt, pass the bolt from the internal side of the furnace through the right-hand contact and out through the window cavity. Then the traction nut is screwed onto the bolt with the long side toward the furnace block, onto the free end of the bolt. So you always use the long side when you're removing the contact cylinders because it's going to push the contact cylinder out. And then you carefully turn the bolt clockwise with the spanner to draw the traction nut inside, which will then push the contact cylinder out of the furnace block. And then you disassemble and remove the tools. And this is a picture of the tools in place to remove the right-hand contact cylinder. Then removing the left one, you place the dome-shaped extractor on the bolt, pass the bolt from the internal side of the furnace through the left-hand contact and out through the window cavity. Screw the traction nut with its long side toward the furnace block onto the free end of the bolt. And it's very important that you position the traction nut so that the flat side on the rim passes under the optical sensor because you don't want to damage that optical sensor. And then you turn the spanner so that the traction nut is pulled in, pushing out the contact cylinder, and again, remove the tools. And this is a picture of the left-hand contact cylinder being removed. And notice that you have the flat part underneath the optical sensor. Now, to install the left-hand contact cylinder, you place the long arm of the plastic alignment gauge and the replacement, which is the shorter contact on the bolt. Make sure the contact fits in the ring on the gauge. Pass the bolt through the internal side, from the internal side through the left-hand furnace block and out the window cavity. Screw the traction nut with the short side toward the furnace block on the free end of the bolt, and position the traction nut so that the flat side is under the optical sensor, and make sure the new contact cylinder is not at an angle. You have to be very careful that you've positioned it straight in. And then you carefully turn the bolt clockwise with the spanner So the contact is pulled into the furnace block, and then you stop when it's flush with the furnace block, and then disassemble and remove the tools. And this is a picture of the left-hand contact being pulled into the furnace block. With the right-hand side, you're going to use the short arm of the alignment gauge. And what you're going to do is make sure the contact fits in the ring on the gauge, and there's a little lug in the ring that inserts into the sample introduction port of the contact. And note that there are alignment marks on the furnace and the contact cylinder, and that's so that the dosing hole, or the hole in the contact, which is over the dosing hole, is in the right position. Now it's going to move a little bit, so sometimes I'll move it in the opposite direction a little bit, just knowing that when you draw the contact in, that alignment mark will move a little bit, and it doesn't have to be perfectly aligned with the alignment mark, but you really don't want it too far away from the alignment mark. Then you pass the bolt from the internal side through the right-hand furnace block and out through the window cavity, so that the long arm of the alignment gauge rests against the furnace block. And this helps keep it aligned, right? But just know it's going to move a little bit. Screw the traction nut with its short side toward the furnace block onto the free end of the bolt. Carefully turn the bolt clockwise with the spanner to draw the contact into the furnace block. And again, it's very important that the contact is aligned straight, otherwise you could break it. And then slowly pull the contact into the furnace block until it's fully seated, and then disassemble and remove the tools. And again, be very careful that you don't scratch the new contact cylinder or the coating on the furnace as well. And then this is a picture of showing you the alignment mark. On the left, you see the alignment mark on the contact cylinder, and on the right, you see the alignment mark on the furnace itself. And then here's another picture of the alignment marks of the contact cylinder and the furnace itself. So again, it's going to move a little bit, but you try to have it move as little as possible because you want that hole in the contact cylinder to be in the right position. And then you put the new shield ring back on the left-hand contact, and that way that the gap between the two contacts is covered. Now, for THGA, the furnace will need to be rocked forward before the contact cylinders are changed. And depending on the model of the instrument you have, it's going to be a little bit different between them. Now, on the 800, you want to make sure that it's moved to the service position before the furnace head is rocked forward, or you could damage the cantilever assembly. So what you're going to do, if you select contacts on the diagnostics window, that will move the furnace down to its service position. After you've finished changing the contact cylinders, then selecting position will return the cantilever to the analysis position. But you want to only rock the furnace forward when it's in its lower position. The 600 has a latch mechanism, and there's two forward positions. The first forward position, you can just rock the furnace forward without touching the latch, but you have to activate the latch to move to the lower forward position, and you always have to activate the latch when you're moving back either from the lowest position or from the middle position. And it's up to you whether you want it completely pulled forward or only partially pulled forward when you change your contact cylinders, whatever's most comfortable for you. On the Z, the Pinnacle 900Z and the T, there's a knob here that you're going to loosen up, and that will enable you to rock the furnace forward. And there's only one forward position on the 900Z and T. Now, these are the tools that you will need to change the contact cylinders. Now, if you had a ZL system a long time ago, the tools were different. These are the updated tools. So it's probably better to have these tools, but you could use the old tools if you needed to. Now, if you're changing the contact cylinders a lot, it's possible that this one could get stripped, and then you would just have to buy another one of these. It's brass, and if it gets used a lot, it's possible. It's also possible that this one might have to be replaced if it's used a lot. But that would only, that would only be the case when you're using them all the time. If you have a fume extraction tower, and that would be on an older model, you want to remove the fume extraction tower first before you change your contact cylinders. And you're going to, before you start, you're going to open up the furnace and remove the graphite tube. You want to leave the pressure cylinder over to the left so you can access the contact cylinders. You want to turn off the instrument. And the switch on the front is just a standby switch. If you want to turn off the furnace completely, you need to turn off the circuit breaker on the back of the instrument, or you could unplug it as well. But it's always best to make sure that the instrument is totally off before you start. So you're going to remove the pressure cylinder that's attached to the front contact housing by loosening the two socket head screws. And there's an O-ring there. When you remove it, make sure it's in good condition. Otherwise, when you put this back on again, if it's not in good condition, replace that O-ring. Attach the removal tool to the front contact housing with the two captive screws on the tool. Use the hex driver to screw the bolt on the removal tool into the tool to push out the contact. And then unscrew the two screws that secure the tool to the contact housing and remove the tool. Okay. For the other contact cylinder, you need to remove the optical sensor, and the optical sensor is right here, and the temperature sensor, which is right here. So you want to do that, remove those before you remove the contact cylinder. So you attach the removal tool to the rear contact housing with the two captive screws on the tool. Use the hex driver to screw the bolt on the removal tool into the tool to push out the contact. Unscrew the two screws that secure the tool to the contact housing and remove the tool. To insert the front contact, make sure the furnace is completely clean and absolutely dry before installing the new contact cylinders. So if you do clean it with any kind of a solvent like isopropyl, I wouldn't use anything harsher than that. You've got to make sure that it's completely dry before you put the new contact in. So you're going to slide the guide and the front contact onto the long bolt, put the bolt into the front contact housing so that the new contact sits in the opening of the housing, put the threaded cylinder into the opposite end of the contact housing, and screw the bolt into the cylinder until the contact is pressed up against the housing. Use the hex driver to screw the bolt into the threaded cylinder, and you pull the contact into the contact housing. And screw in the bolt until the rim of the contact is flush with the contact housing. And of course, you want to make sure that it's straight in the housing and it's fully seated. If the contact is installed slowly, you will feel resistance when it's fully seated. So, and so here are some pictures of the contact cylinder being installed. Okay. And again, you don't want to scratch any of the coating of the furnace when you're doing this. So inserting the front contact, screw the bolt out of the threaded cylinder. Carefully remove the tools, taking care not to scratch or damage anything. Blow out any loose graphite particles. Check the O-ring on the pressure cylinder. Replace it if it's damaged. Make sure it's positioned correctly. And then push the pressure cylinder carefully onto the front contact housing tighten the 2 screws to secure the pressure cylinder to the front contact housing. So now the front contact is done. The rear contact. So this is where you have a guide. So you have the bolt, the guide, threaded cylinder. So slide the rear contact onto the guide and slide these 2 parts onto the long bolt. Put the bolt into the front contact housing so that the new contact is in front of the rear contact housing. Make sure the sample injection hole is on the top. You certainly don't want to install it and then find that it's upside down. And you want to make sure it's properly aligned to the opening. And if you install it at an angle, it will break because it's made of graphite. So just be careful it's positioned correctly before you start installing it. Put the threaded cylinder into the opposite end of the contact housing and screw the bolt into the cylinder until the contact is pressed up against the housing. Use the hex driver to screw the bolt into the threaded cylinder and push the contact into the contact housing. Screw in the bolt until the contact is flush with the contact housing. Make sure there's no gap between the contact and the housing. Okay. And then here's some pictures. Screw the long bolt out of the threaded cylinder. Carefully remove the tools. Blow out any loose graphite particles. Check the condition of the O-ring on the optical sensor. If it's damaged, replace it. And you always want to have some spare O-rings as well. Make sure the O-ring is positioned correctly. Push the optical sensor into the rear contact housing. Tighten the 2 screws to secure it. Replace the temperature sensor. Make sure the clear insulation washer is under the temperature sensor. And then if you have a fume extraction unit, you would then replace that as well. Now, whenever you change contact cylinders, it's always a good idea to have 2 sets on hand, because there's always the possibility that something could get damaged when you change the contact cylinders. And in case that happens, it's rare, but it's always possible. You want to have another spare set so that you don't end up with a system that you can't use until you get another set. All right, so that is my portion of the talk.
And yeah, and thank you, Sarah. That's a really good overview of a maintenance. And looks like we have some time for questions. So if you use, Sarah, can you advance the slide, 1 slide?
Okay, yep.
Thank you.
Okay.
So yeah, so if you use the functionality in GoToWebinar, you see there's a questions pane, and yeah, feel free to submit any questions there, and we'll try and answer it. Sarah and I will try and answer what we can. All right, Sarah, we've got our first question here. I've got some contamination using a 2 gram per liter magnesium nitrate matrix modifier at for my aluminum determination. I've already changed to a pre-mixed solution from PerkinElmer. It's gotten even worse.
Okay.
Do you have any clue how I can fix this blank problem?
So, of course, the modifiers are always diluted down. So the magnesium nitrate that you get from PerkinElmer is a 1% magnesium nitrate solution, but we tell you how much magnesium nitrate you need. So with the 1% magnesium is actually 6.2% magnesium nitrate. So the first thing I would do is to make sure that the solution is made up to the correct concentration of the modifier. And we do have documents on telling you how to make up the modifier from our solutions that we sell. and it's going to be made up differently for the HGA versus the THGA. So the THGA modifier strength is 1/3 the strength of the HGA modifier. So the first thing I would do is make sure that it's made up in the correct strength. And for the most part, our modifiers are very clean. I mean, we were very careful in getting the source of modifiers. So I suspect it's either made up too strong, and that will give you more background. If it's too much, too strong of a solution, it will give you more background, not less. So that's the first thing I would do, is make sure it's made up correctly. And you can call AA Tech Support, or you can send an email to aatechsupport@PerkinElmer.com and ask for those documents that will tell you how to make up the modifier. Of course, as always, whenever I make up a modifier, I make it up on the scale. So that way, keep it clean.
Another thing that could be happening, from my experience, is just the whole system is more contaminated somehow. So something got contaminated. Another way, as Sarah said, those matrix modifiers are selected for their ultra high purity. I've seen some get modified by get contaminated by, just sitting out in the lab. Somehow they got contaminated after opening them. So you may want to procure another one if that one for some reason got contaminated. So I have seen that.
What I will do is I'll take a plastic bottle that I know is cleaned, and you could always clean it with 10% nitric and then rinse it out very well with DI water, put it on the scale, tare away it, and then put the amount of modifier that you need there, and then, dilute up to the weight. And don't make up too much modifier at a time, because every time you open up the bottle, you are contaminated. And of course, the cup you put it in has to be very clean as well.
Yeah. Yeah, so watch out for contamination of the cups. I find sometimes they'll get contaminated and then repeatedly going back in. The next question, are there videos to watch on this procedure? I'm assuming it means like the contact replacement procedures and so forth.
So we do have a ZL video that was made several years ago. I think it used the original contact cylinder tools. So I don't think we have a video that has the new tools. And we have a very old video that covers the HGA contact cylinder removal. So that might be something useful.
Yeah, I mean, this will be on demand as well. We'll send out a link, so you can follow through some of this, the picture tutorial. But yeah, it's not really a video per se. We have another question. I have been seeing a background that is going below the baseline. What could be the cause of that?
Okay, so usually if the background's going below the baseline, it means the furnace is misaligned. That's generally the tip-off, because what's happening is the detector is seeing black body radiation from the graphite tube. So if the light from the lamp is not going through the center of the tube, or you'll pick up black body radiation. So generally, if it's going negative, it is furnace misalignment. It's also possible that you have very high levels of background. That also could do it. And if you have an HGA system, it's possible if you have structured interference, but generally negative means that your furnace is misaligned. So if you have a Pinnacle system, probably best to have the service engineer involved if you suspect your furnace is misaligned.
Yeah, that's exactly what I would say. Yeah, check alignment. That's usually the first thing I would do. as well. But yeah, if there's a lot of TDS, a lot of solids in that material as well that you're putting into the furnace, you can get a background absorption there as well, and it can be an artifact of overcorrection. We're on the top of the hour. Let's see if I can find a couple more. Someone asked, is there a part one? Yes, that was on flame maintenance. I got a few more questions here. What is the typical BOC time when you run with an EDL lamp? Sarah, do you have a quick answer for that?
I mean, you just leave it the default. As far as I've never changed the BOC time. The instrument knows when to start the BOC reading, but I've never changed the time. Aaron, have you?
I usually leave it at default as well. It's you know, usually it's, I think if BOC is about 2 seconds or something like that. So I usually don't modify it either. If anything, if something you know, if it's a read delay because you're using some sort of flow system, then that's what you modify, not the BOC usually. I need to test borate. Do you think AA is good for boron in terms of selectivity and sensitivity?
I'll let you answer that.
I mean, perhaps. I mean, we kind of need to know concentrations. Please, you know, reach out to us with more information there.
I mean, the Guide to Techniques and Applications will give a listing of detection limits, instrument detection limits by AA,
Yeah.
ICP, mass spec. So I would always start at the Guide to Techniques and Applications, and you generally want to stay 10 times above the instrument detection limit. So
yeah, also the Flame Cookbook helps as well, which is available. New autos, we had a comment, new auto sampler cups need to be wash soaked in nitric overnight or for using them. Yeah, I mean, it's always good to soak your auto sampler cups. Again, we're dealing with very small aliquots of sample, so any contamination will be kind of magnified with graphite furnace if those cups are contaminated. So make sure they're clean, or whatever source they're coming from.
At the very least, you need to rinse them out a few times with whatever you're putting into the cup, but it's best if you can soak them in 10% nitric overnight.
Mm-hmm. We had a couple questions like this repeated. What are the number of cycles for a graphite tube until replacing the tube? And then we had a similar question, was the number of, you know, cycles a set of contacts. I mean, from my experience, the tube really depends on the sample type that you're using. So, you know, what's in the matrix, the dissolved solid content, etc. So, if they're very aggressive samples, you know, you can get a couple hundred, you know, firings. It could be more if they're cleaner samples. So, what's your experience, Sarah?
Yeah, I mean, I know way back we used to have a test where it was, I think it was a chromium standard, and you had to get at least 300 injections out of that. But I have heard people getting 1,000 injections out of a tube, but that would be from a very clean sample.
Yeah.
But if you're analyzing acid for impurities, and ideally you don't want to have more than 10% acid, but I've heard of many customers running it straight. You're not going to get that many firings out of it if you have the more acid you have, and also the type of acid can affect the how many injections you get, and that's something you're going to have to determine, and then you can tell the software to notify you when you get to a certain number in terms of injections. But I would just, you know, initially keep an eye on it, look at the tube. Usually you can see that whether it's good or not. And it is very important, especially on a ZL, but no matter what furnace you have, you don't want the tube to break while you're running. And especially with a ZL, you probably will damage your contact cylinders if the tube breaks. So I would be prepared to change the contact cylinders if the tube breaks during a run. But again, it depends very much on what samples you're running. And the same thing for the contact cylinders as well. But again, if the tube breaks, you've pretty much damaged the contact cylinders.
Yeah, I mean, the contact cylinders will definitely last longer than a tube, right?
Yes. I've heard it, well, I'm trying to think, I was talking to somebody. At least 5 tubes of contact cylinders, but I think longer than that. Of course, it's, I'm not running all the time, so I don't pay that much attention to it. But visually, you could see a lot, in terms of whether they're in good condition or not.
Yeah, from my experience, I used to see it, how much carbon was starting to come off them. They're kind of breaking down, right? And again, it's related to the sample type, how much acid, the type of acid that you're putting in there, that definitely affects contact cylinder and tube life.
And residue as well. So
yeah.
say your blood analysis, from what I've heard, you're going to get so much residue in there that at that point you have to change your graphite tube as well. So, and I guess the contacts as well.
And firing temperature too, atomization temperature too, right?
And the length too. So
yeah,
if you're
and the length.
Refractory element, where you have a long atomization time, of 8 seconds or so, and then you'll need a longer clean out time, that will affect it as well.
I had a question. Are there webinars for the use of the software? There are some videos, but we're in the kind of works of making videos/webinars for various software usage, really to be used by the application scientists and so forth around the world to help support our customers. So that's a good suggestion. We'd definitely like to have a lot more of them available. I have a question. Someone said, I can't get a good blank value for zinc on furnace. Well, zinc's always a tough one, right? In any atomic spectroscopy technique, it's easily contaminated. So usually it's contamination. Usually it's something, one of the reagents or something like that has some background zinc.
And the operator, yes, zinc is very sensitive and very prone to contamination. So you have to be a detective and try to figure out where it's coming from. And that's probably a case where somebody would cover the furnace when they're not using it. But that's a difficult element to get a good blank on.
Yeah, not even on Graphite Furnace. I see it on ICP and ICP-MS. It can be a tough one. He said, I'm looking for, so the pyrometric test with 1200C and Hga. I don't know what.
I think he's talking about calibrating well, that would be something that service would do, calibrating the pyrometer. It's that little tiny set screw that's on top of the pyrometer, and yeah, I mean, it is, you just move the set screw when you're at 1200 degrees and you look at counts, but that would be in the base module.
Yeah, that's a service related function. Yeah.
And I don't know if it's that critical. It doesn't seem to change it that much, but that is a service function where you move the set screw based on the counts in the service module. So that's what service would do.
Yeah. That's actually a really good comment. This comment, not a question. One attendee says, I usually get 250 to 300 firings for selenium and aluminum determination in blood. So yeah, that's about right. So blood, I typically find it's fairly complex matrix. There's a lot of carbon and other things in there. And 250, 300 firings, yeah, that's about right for blood. It's pretty good. And then I have another comment. sounds like the contact cylinders around 7,500 cycles is what another user is getting. That's good to know. And then I have another question. It's more of an applications thing that they're trying to get help with beryllium. Any tips?
Again, I would send an email to the AA Tech Support mailbox. I know I've collected a bunch of application articles over time, but yes, you can also contact your application person, what we used to call product specialist. They also could help, but I know I have a bunch of application articles and see if I have one on that. But yeah, I guess start with your application person, and application articles can also.
I totally agree. I mean, it's when you get into specifics on application, you need to know, matrix, the, concentration levels. There's a variety of factors that need to be considered. So yeah, I agree. Okay. I think that is it. Well, thank everyone for attending. You can go next slide there, Sarah. Yeah, just thank everyone for attending today. This will be posted to the web for on-demand type of viewing. So when you get a chance, you can review this if you're doing any maintenance on your graphite furnace. So thank you everyone for attending today's webinar. Again, if you have any questions, please contact myself or AA Tech Support email that you see here on this slide. And then you will receive a follow-up email within 24 to 48 hours with a link to view this recording. So on behalf of PerkinElmer and myself and Sarah, thank you for joining us today, and have a great rest of your day. Goodbye.